So the minute you start simplifying, usually you're going to think about a factor tree. Well, what goes into 108?
9 and 12.
9 for sure, because it adds up to 9. 8 plus 0 plus 1 is 9. Okay, that's how I knew 9 went into it. It's actually 9 and, we're going 1, 2, 12. Okay, is that good enough? Is that all the factor tree I want to do? No, what am I looking for? Pairs. I'm looking for pairs. Do I have pairs yet?
3.
I don't have pairs. I will have pairs because Jason, what is 9 going to be? 3 and 3, right? That'll give me a pair of 3s. Okay? But I still need to go down on the 4. I need to go down on the 12. So Trey, what's 12 going to be?
4 and 3.
4 and 3. Or you could have used 6 and 2, it wouldn't matter. So 4 and 3, and then 4 is 2 and 2. I have a pair of 2s. So I have 2 pairs. I have a pair of 3s and a pair of 2s. As I bring them out, they become only 1, right? The pair comes out as a single 1. Everybody with me on that? Like when you go to get pictures taken at a dance, the whole pair gets 1 set of pictures. You with me? So we're going to bring out a 3 and a 2. What are we going to do with those 2 pairs when we bring them
We
out?
don't put them in outside.
You're going to put them outside, but what are we going to do with the 3 and the 2? Multiply them together. So I'm going to have 6 on the outside. How did I get 6?
You get multiplied and
3 times 2. Don't add them. Okay? And don't think it's 3 times 3 times 2 times 2. Right? It's a pair of 3s and a pair of 2s. That's how we got it. What happens with this 3?
It stays under.
It has to stay home. It doesn't have a date. It doesn't have a pair to go with it. Right? So it has to stay under the root. Okay. How about the x's? How many pairs of x's?
13. So
Well, there's 13 total. There's
So it's
6
6.
pairs with 1 left over.
Right.
I don't remember who I saw do this, but I think it was Trey, I think, did this. And he would cross out that x to the 13, write x to the 6th out here, and then leave an x under it. I wasn't sure if it was Trey or Z. Was it you? Okay. And I like that. I like that he crossed this out, put an x that says there's 1 left, right? And then put outside, but I have 6 pairs coming out. Everybody see how that was done?
Yeah.
Okay, how about the 20s?
There's.
Or why did 20?
10.
There's 10 pairs. Is there any y's left under?
No.
No, so I've got 10 pairs coming out. Okay, what's left then? Square root of what?
Oh, so it's.
What has to stay home because it
So
doesn't have a
X
pair?
does and.
The x and the what?
6.
And the 3.
3.
So 3x is what's left under the root. Pretty simple.
Those are going to the.
Everybody with me on that?
Yep.
Pretty easy. Okay, now here's something else that we're going to learn today. You can't leave a root in the denominator. Okay? If you leave a root in the ground, it grows weeds. That's the easiest way to remember it. Can't leave a root in the bottom. Is it okay to have a root in the top? Yes. Okay, those are easily seen. You can pull out the weeds, no big deal. You can't have a root in the denominator. It'll make weeds, okay? No roots in the denominator. So that's what we're going to do on these. How do I get rid of a root? I got a question. What's the square root of 2 times the square root of 2?
4.
It's
1.
square root of 4, I'll agree with that. Which is,
2.
say, huh?
Hmm.
What's square root of 6 times square root of 6?
6.
Six.
3.
You can say square root of, you could say square root of 36, but square root of 36 will still be what? So no matter what you have the square root of, what's the square root of Trey times the square root of Trey?
Trey.
It's going to be Trey.
Oh,
It just comes out of the root. Square root of Carson times square root of Carson? It's just going to be Carson. It'll come out of the root. You with me? So the easy way to get rid of a root is to multiply by the same root. That's something you might want to write in your notes, honestly, because you're going to have 10 questions right after this that are on the board. Okay? But that's something I might put in my notes so that when I get there, I'll remember. The easiest way to get rid of a single root, is to multiply by that same root. So, Briley, which one is it? Briley, how do I get rid of this root of 6 off the bottom then? Times it by itself, right. Times it by square root of what? 6. Top and what? Bottom. Okay. The bottom is easy because what's the square root of 6 times the square root of 6? 6. The top has to be factor tree. And I'm going to show you a trick here. Do not multiply the 6 and the 27. Why? guess what you're gonna have to do right after you multiply them? A factor tree. What, well, you already have a factor tree. You have a 27 and you have a what? 6. So don't multiply those. Just say, hey, I've got a 27 times what? 6. Now start the factor tree. I'm going to go upwards instead of downwards. My branches are going to grow up on the tree just because it's on the top. Okay? So what goes into 27? 4 doesn't go into 27.
3 and 9.
3 and 9.
I knew that.
And 9 is what?
3 and 3.
3 and 3. Do I have a pair of 3s?
Yeah.
Yes. Wait, 6. Is that all the way factored?
3 and 2.
No. Will it help if I factor it?
Yes.
Yes, because
Three
it
and
will allow
two.
me to have another pair of 3s here.
3 and 2.
So 3 and 2, pair of 3s. The 9's gone, remember, and the 6 is now gone. And the 27's gone. I have a pair of 3s and another pair of 3s. 3 times 3 is what?
9.
9. Roots of, what's the only thing left under the root that doesn't have a pair with it? 2 over what? 6. Now, here's the other thing you need to remember about roots. You can reduce, and you want to write this in your notes, you can reduce outside to outside or inside to inside. But you cannot reduce outside to inside. And maybe I'd just write that last part down. You cannot reduce outside to inside. Okay? In other words, can I reduce the 9 and the 6?
Yes.
Yes, they're both what?
Outside.
Outside of a root. Can I reduce the 2 and the 6?
No.
No. One's out inside, one's what? Outside. You can't reduce inside to outside. Everybody got that? That's the easiest thing to write in your notes. You cannot reduce something that's on the outside of a root with something that's inside the root. So, these reduce. What goes into both 6 and 9?
3.
So this becomes
3 over 2.
3 roots of 2
Over 2.
over 2. Can these 2's reduce out?
No.
No. Do not reduce outside to what? Inside. That's super important. Okay, I'm done. That's this one. Okay. Notice the steps we took. We did what Briley said first and multiplied by root of 6. When we multiplied it to the top, though, what did we decide not to do?
None.
We decided not to multiply that, actually. We decided to write it as 2 factors, factor tree it up, because everything was under the root. To bring it out, we had to have pairs. Everybody with me so far? This is tricky, a little bit hard right there. Same thing's going to happen right here, only can you simplify before you start multiplying by the... Could I multiply by square root of 98?
No.
Yeah, but the problem is that I'd have a big number on the top to have to try and figure out what to do with it, right? Can you factor tree it and then times it? Yeah, that's what I'm going to do on this one. So Matt, what do I get when I factor tree 98? Matthew, what will I get? What goes into 98? Well, it's even, so 2, right? What's half of 98?
49.
49. And you can use a calculator to do that. Just do 98 divided by 2. It tells you it's 49. Hey, 49 is a perfect what?
Square.
Remember we wrote down a list of perfect squares? Make sure you have that list of perfect squares because it will help you a ton. Because if you can get a perfect square, there are 2 what? 7s. Which means I got a pair of what? 7s I can bring out. So now there's a 7 on the outside of the root. But there's still a root of what?
2.
A root of 2. That had to stay under. There was no pair to go with it. Root of 7. Now that we've simplified that bottom root, how do we get rid of the root of 2? What's the easiest way to get rid of a single root? Multiply. By what? Do not multiply by 7.
Itself.
Just itself. So root of 2 needs to be multiplied by what? Root of 2. What's root of 2 times root of 2?
2.
Root of 2e. Okay, now.
Ratatouille.
It's 2. 2 times 7 is?
14.
14. But if I multiply the bottom by root of 2, this is where kids mess up. If you multiply the bottom by root of 2, you have to multiply the top by what? Root of 2. And that's where some kids mess up. So I multiply this by root of 2. Can I multiply under to under? Yes. You can multiply outside to outside. You can multiply inside to inside. But you can't do outside to what? Inside. Outside to inside doesn't work. But if they're both under, we can. So this is inside to inside. What's root of 7 times root of 2? Root of what?
14.
14. Do those 14s reduce?
Yes. No.
No, why not?
That's outside the inside.
One's outside, one's inside. You with me? That's the super important part. Do not reduce something that's under a root with something that's what? Outside of the root, okay? It's like, even though these cows look the same, this one's your cow and this one's still in somebody else's corral. So, but they look the same, it don't matter. If it's outside to inside, you can't reduce, okay? Or you can't multiply either. Okay, let's do the next one. This one right here. Okay, is that gonna factor tree and simplify in the bottom?
Yes.
It'll factor tree, but will it simplify? What does it factor tree to be? 5 and 2. Will you have a pair to go with the 2s? No. Will you have a pair to go with the 5s? No. So you might as well just times by square root of what? 10, top and bottom. Okay. What's square root of 10 times square root of 10? 10 on the bottom. 3 roots of what? 10. Can I take that 3 and distribute it into the root?
No.
And write root of 30?
No.
Can't do that. You can't multiply outside to what? Inside. Okay, so that's my answer. The 3 doesn't divide down with the 10. If it did, could I do that? Yeah, if it was like 3 and 9, it would be fine, but I can't do anything more than that. Now notice that this one looked very similar to this. Do you think it's going to be the same answer?
No.
No. What am I going to multiply top and bottom by here? Root of 10. Here's why it's a little different. What's root of 10 times root of 10? 10. But the top, can I multiply those now?
Yes.
Could I multiply these two?
No.
No, I couldn't, but I can multiply these because they're both under the what? If they're both under, I can multiply them. So this becomes root of what on top?
30.
Now, can I reduce that 30 with that 10?
No.
No, because the root of 30 is under the root and the 10 is what? Outside. That is the most important thing, if you haven't noticed, that you need to remember is you can't multiply outside to inside. You can't reduce outside to inside. You with me on that? You can only reduce if they're both on the outside. You can only multiply if they're both on the inside, things like that. Okay? Inside to inside is okay. Outside to outside is okay. But inside to outside doesn't work. Okay, let's try this next one. Okay, what should I do? Both top and bottom, Taylor.
You need to. Factor.
This problem.
Good. Times it by the square root of 3.
Square root of 3, top and bottom. What's the bottom going to be then, Taylor?
3.
Okay, I'm going to put the 3 down here. The top is going to have a square root of 3. Can I multiply those two that are underneath?
Yeah.
Yeah, but do I want to?
No.
I'm going to have to factor tree anyway. So don't do that. Just put 675 times what?
3.
3. Now, okay, this is tricky, but let's see if you know it. Ashton, what do we know goes into 675?
5.
How do you know that, Ashton?
Well, because it ends in 5.
Because it ends in 5. Very good. So we know 5 goes into this. Now I don't know what it goes into it, how many times. I need a what to do that? Calculator. Will you do that for us, Mason? Just do 675 divided by 5. What is it?
135.
100 and, what was it?
35.
35. Okay. It ends in what?
5.
Now this is why I like using a calculator, by the way. Because now I have that 135 sitting there, I can divide it by 5. So just go 135 divided by 5.
27.
And you get 5 and 27. Hey, 27 is
3 and 9.
3 and 9, and 9 is
3.
3 and 3. Can I take out a pair of 3s?
Yes.
Can I take out another pair of 3s?
Yes.
Can I take out a pair of 5s?
Yes.
Was there anything left?
No.
135's gone, the 27's gone, the 9's gone, everything comes out. So I've got 5s and 2 pairs of 3s. So 3 times 3 times 5. What's 3 times 3?
9.
9 times 5.
45.
45 over what?
3.
3. Hey, 3 goes into 45. Because 4 plus 5 is what? 9. So that
15.
reduces, what is the answer?
15.
The answer to this question is 15. Now, I want you to do this just so you can see kind of how it works. Punch in on your calculator, square root of 475. It'll give you some decimal. Did you get it?
What?
Square root of 675. Oh, sorry, I said 475, but I meant 675. Square root of 675. Do that on your calculator. What is it?
25.9.
25.9. Did somebody else get it? Square root of 675. Is that what you got? 25.9-ish, right? Now hit divided by, hit your divide by key, and then hit square root of 3. Now square root of 3 is a decimal too, but somehow those two decimals end up being what?
15.
15. It's weird, but that actually, you could do it on a calculator and this would come out to be 15. Why don't we do all these on a calculator then? Is that going to come out even?
No.
It's going to be some decimal. But this is how the answer needs to be given. It needs to be given in root form, radical form. It doesn't need to be given as a what?
Decimal.
As a decimal. So this one happened to work out that it was an even number, so I could have done that one on my calculator. But are all the rest of these going to work out on your calculator?
No.
No. None of the rest of them will. Okay. Shai, what should I do on this one? It's the same process I've been doing the whole time. What should I multiply the bottom by? Yes? 14. Square root of 14. Multiply by the exact same thing, just stay under the root. So square root of 14. Because, what's square root of 14 times square root of 14?
14.
14, it comes out of the root. See? You have to have a pair to come outside, right? So you're going to create a pair by doing the same thing. Okay? But the top, do I want to multiply 2 and 14? I mean, I could, it's easy, it's 28. But is that going to help me much?
No.
No, I'm going to have to factor tree anyway. So I might as well just write, hey, it's 2 times 14. Factor tree the 14, that's 2 and what?
7.
Hey, I got a pair of
2's.
So it becomes 2 roots of 7x. How come the x just stayed
Wait,
there?
why is, where's the X from?
It's right there.
Oh.
But did it come out?
No.
No, there's no other x to come out with it, right? There's no pair. So it has to stay under. There was no pair to go with the 7. It stays under. There was a pair of 2's. I brought it out. Over 14. Am I done? No. Can I reduce?
Yes.
Yes, because I have outside to outside here. So what do I reduce? Do I reduce the 7 and the 14?
No, 14.
Or the 2 and the
2
14?
and 14.
2 and the 14.
Which is
So,
7.
which is what?
7.
7 on the bottom, and then I have square root of 7x on top. Can I reduce those 7 and just have square root of x as my answer? No, because one's what?
Inside, one's
Inside,
outside.
one's outside. That's most important. Don't reduce inside to outside. Okay, next one. This one's different. There is a binomial on the bottom. What do I mean by that?
More than
This is different than every one of the problems we just did.
More than one.
There are 2 terms. How do we know there's 2 terms?
Because it has a.
Wasn't there 2 terms on the other
Because there's
one?
that plus sign.
It's not because something's outside and inside. It's because
No,
what?
because there's a plus sign.
Plus sign or a what? Minus sign.
minus
Write this in your notes. If there's a plus or a minus, you have 2 terms. The way you get rid of a binomial radical is to multiply by the conjugate. Write that in your notes. The way you get rid of a binomial radical is to multiply by a conjugate. Now, you don't know what a conjugate is,
No.
but I'm going to teach you right now. Okay? So a conjugate is the easiest thing in the world. It's exactly the same, only the middle sign is different. So I'm going to multiply by 3 roots of 2. Instead of plus 5, I'm going to write what?
Minus 5.
Minus 5. I got to do that bottom and top. 3 roots of 2 minus 5. Now, why am I doing that? You're going to see.
I have no idea.
You're going to see why. It's kind of cool. Something that is irrational, which is a square root, will turn to be rational. I'm going to turn something irrational into something rational. And the reason is because I'm going to multiply a square root to itself. Just like we were doing up here, square root of 14 times square root of 14. Well, here we have square root of 2 times square root of what? 2. Watch how this is done then. I'm just going to use the distributive property. And I'm going to distribute this 3 roots of 2. What's 3 roots of 2 times 3 roots of 2? What's 3 times 3?
9.
9. That's 3 times 3. What's root of 2 times root of 2?
2.
What's 9 times 2?
18.
18. Now, watch this part. This is the tricky part. This is why I'm multiplying by a conjugate. That's going to give me negative 15 roots of 2. Do you agree with that? Yeah. Will you take the cover off that, please? Now you have to unroll it.
Wait, negative 15.
And you might have to put it on the way. Just a second.